Hello class, it's Professor McDonald. I'm doing my weekly recording where I go through the questions you sent to my Lumen-Ohm inbox using the Message Instructor feature from inside your guided learning assignment that's due probably very soon, and the recording is usually very timely. I'm just showing you, in case you're not sure, how to access and begin your Lumen-Ohm assignment. Notice that I used a free trial. You can also get the code and go ahead and enter it right away, but if you're waiting on purchasing the code, please don't wait. Just go ahead and start your assignments. And when you're working and you want to have me do a question for you on the weekly recording, you can use the message instructor feature, which will send me a copy of your question. You can attach work in the form of a file or a picture, or just type it in there. You can do a table, all kinds of good stuff there. There's some math editing features here. Also, just tell me, I'm not really sure what to ask, but I need help. I just like to hear anything you can help tell me is helpful, because sometimes there are actually videos along with the question. Like here, you see there's a video. So if students watch that video and it doesn't help, it's always very useful for me to know that you did watch the video and that you still need help with something. And any information will make my recordings much higher quality for helping you. I also like to recommend that students use the SLC tutoring services, which you can do online or in person, and ask them for proof of attendance. You can also do drop-in appointments, but the proof of attendance would be used to upload when you are ready to take your test, or when you're going to get ready for the test even. There's always a testing module, and the testing module contains the reference packet, the extra credit assignments, the question bank is extra credit, the practice test is extra credit, and the upload SLC is obviously extra credit. So you can save your receipts when you get help from the SLC, and you get assistance a little quicker than having to wait for the weekly recording. And a third option still, if you need more immediate help and you want to work with me, you can always come to my office hours on Zoom by using the link under my picture there, and then setting up an appointment using the Calendly appointment setting option there, so that we can meet on Zoom and I can help you. So with all that said, let's go ahead and answer the questions you sent me. So the first one here was actually from the starter assignment, and the starter assignment did not count for a grade, but I did get this question from a couple of different students, so I'm going to go ahead and answer it. First of all, there is an interface that allows you to use the fraction bar here, and you can do a second fraction for the numerator. As you can see here, there's a fraction there. So I can use it twice to enter what I want, and then 2 in the top, and then I'm using my down arrow key to get to the next level, and again my down arrow key to enter in the rest. So really that's all you needed to do. There's a way that you could do it without using that feature at all. You can do it with just parentheses, and what I recommend is you start with 2 sets of parentheses and the fraction bar. And see how it set up a fraction for me? Again, all I did was I did parentheses, then the division slash on my keyboard, so the forward slash on my keyboard, and then another set of parentheses. Now I can go inside the top set of parentheses and do 2 divided, so I just used my forward slash again, and then I'm going to do 3 plus x, and it's kind of self-explanatory. I think I'm just entering in what you see typed there. Okay, so that was the first question. Okay, here is the next question I was asked, and this one was question number 14, I think, from GLA 1. Yes, that is correct. Number 14 from GLA for lesson 1, number 14. And all we need to do is find the regression line for this given set of data. So I'm going to copy it, and I recommend using your cursor outside of the edges of the table because it just copies and pastes a lot better when you do it that way, as opposed to having your cursor inside the borders of the table when you go to select your data. So I'm going to select it, copy and paste. And then once I have that, I'm going to find the regression line, like it says, the regression line. So that is where we first make a scatter plot using our data. So I'm going to select the data. I'm going to go to Insert, then click Scatter Plot. And now you can see the dots and how they kind of are making a line pattern. And now I'm going to right click the dots and add a trend line to get my regression line. Okay, so that's your regression line. Now what they asked us to do was to give the equation of the regression line. So notice that over here, the tray that opened when I created my trend line, if I scroll down, there's an option to display the equation on the chart. And that's very convenient because now I can see the answer that I need to put in to finish my um, homework question. Okay, so we see the regression line has a slope of, it's probably kind of hard to see, it's a little tiny there. The slope is 0.357. So if you remember y equals mx plus b from algebra, your slope was always the one that was attached to x. And then your, and it says 2 decimal places, I have to point that out. We always want to follow the rounding recommendation. So I'm going to round this to 0.36. And then for the y-intercept, it's going to be 15.46 when I round it. So 15.46. And that's it. And that's all for that question. All right. And the next question I have is number 15 from GLA 1 again. And what we see is it says the following table shows retail sales in drugstores in billions of dollars in the US for years since 1995. Wow, so these retail sales are actually billions of dollars. Really need to open a drugstore. And over here we have years, except they're not years that really make sense at like 1995, but they're years since 1995. So 0 years would mean this was corresponding to the year 1995. 3 years would mean 1998, and then 6 years would be 2001, and so on. Then it says, let S of T be the retail sales in billions of dollars in T years, right, since 1995. So this is your T column right here, your year. That is your T variable. And a linear model for the data is F of T. So S of T would be the real function if one exists. But F of T is going to be used to model the data that we have here. And so when linear regression was run on this set of ordered pairs, this is the best line of best fit, the least squares regression line that was created by whatever software was used to do that. And here is the scatter plot of the ordered pairs along with that same, this line right here, y equals mx plus b, except it's f of t instead of y, and it's t instead of x, but it means the same kind of thing. Y equals mx plus b, that's a line equation. So this line right here that's going to, is pretty close to the dots, is this actual line equation. And it says, using the above scatter plot, decide whether the linear model fits the data well. So I'm just looking to see if the line is fitting the dots pretty close, and it is. So I would say it looks just by visual inspection to be a good model for the data. Then we want to estimate the retail sales in 2016. So we're going to come up with a number of billions of dollars that would have been sold in 2016 based on the trend that we're already seeing in these given ordered pairs. But we're going to use this model, so we don't have to come up with the regression line ourselves. We're just using it to answer the questions. So we're going to do some good old-fashioned algebra type stuff here. We're going to take our linear model and go ahead and use Excel side by side here. I'm going to go ahead and make a new sheet. And I'm going to just put in my line equation is y equals, well, I guess I'll use f of t, why not? So it's sales, that's what it's representing. The sales are going to be estimated using this calculation, 9.44 times t, and then plus 84.182. So if I'm going to answer this question, which says to use the year 2016, then I just need to turn 2016 into a year. So how do I do that? Well, remember, T is, I meant to say, I think I misspoke. Let me say that again. We're going to turn 2016, the year, into a number of years that have passed. So we're going to turn it into T equals a number of years that have passed since 1995, right? So if we just do 2016 minus 1995, we'll get the difference, the number of years that have passed. So there's been 21 years that have passed since 1995. So now I'm going to use that value of t in this calculation to find my number of sales in billions of dollars. So the sales in 2016 are estimated to be equal to 9.44 times the t value of 21 plus 84.182. All right, now notice you always have to put the equal sign in first when you're doing a calculation. Notice the asterisk is my multiplication symbol, and then I have, of course, the plus sign. And when I press enter, I'm going to get an answer, 282 billions of dollars in sales is what my model is estimating would have been the amount of sales for 2016. So in billions of dollars, I'm going to put 282 there. See how we're doing so far. Okay, good so far. Now the last part. Use the model to predict the year in which sales will be 240 billion. So now we are predicting the year, okay? Instead of estimating the sales, now we're estimating the year, right? Or predicting the year, as they're saying it, same idea. So now I've been given the sales, so I'm going to replace using the same formula up here. I'm going to write my sales as 240, and that's going to be equal to 9.44 times t plus 182.182. Or actually, I totally messed that up. That was supposed to be 84.182, right? Now, I'm going to use regular algebra. So you've done this before if you've ever taken an algebra class. Even a beginner algebra class, you probably learned how to solve for a variable or solve for an unknown using inverse operations. In other words, we're going to undo all the math that's happening here until t is all by itself. And as long as we do the same thing to both sides of the equal sign, it's all good. So we're first going to subtract this number from both sides so that I'm going to get on the left, I'm going to get 240 minus the 84.182. And then on the other side, I'm going to have just 9.44 times t, right? And then I have one more step to get t up all by itself. And since I'm doing 9.44 times t here, what I want to do is the opposite of multiplying and divide both sides of the equation by 9.44. So what's going to happen is I'm going to end up with just t on the right there, or equals, t equals. And on the left, I'm going to take this value that's contained here in this cell and divide it by 9.44. And so that gives me an answer of t equals 16. And what does t represent? Years since 1995. Okay, well, that's all well and good, but what we were asked was to predict the year, not the number of years, but the actual year. So we need to turn this number of years into an answer that is more like the 2016, right? We need to put in an actual year. So T represents the year since 1995. So if we take 1995 and add on this value right here, what we get is 2011.5. Now, who knows anyone who was born in 2011.5? No, we don't. We either know people who were born in 2011 or people who were born in 2012. That's how years are expressed. And when you're halfway through a year, you're still in that year, right? So 2011.5, even though mathematically we might want to round that to 2012, it doesn't make sense to do that here because what we're saying is when were the sales hitting exactly this amount of 240 billion according to the model. And so we're still in the year of 2011. So that should be the answer. And that's it. And I believe that was the last question. Let me double check. Let me pause for a moment. Okay, there was one more question, and I forgot to say which question this one was from GLA 1. This one was number 15, I believe. And now we're going to do this last one, which is number 10 from Guided Learning number 1, GLA 1. I don't think we're going to actually need this spreadsheet. Let's read this here. It says a correlation of R equals 0.85 is found between weekly sales of firewood and cough drops over a 1-year period. Which of the following is true? All right. Either A, there is a pretty strong positive linear relationship between sales of firewood and cough drops. All right, well, what is this value here? That is R, the correlation coefficient. And so this tells us the amount of linear strength. Now, R can be on a scale of -1 to 1. So the linear correlation coefficient, let's look at a little quick sketch here. Here's my number line for the linear correlation. It's got a long name, coefficient, R. Well, in the center would be 0, which means no linear correlation at all. And then you have over here, the best you can do is +1. It's almost like 100%, right? So this is the perfect positive linear for line, because we're only talking about lines here. There are other types of correlation that you would not use this measurement for. Perfect positive linear correlation. So that would be for a line or a set of dots that looked perfectly straight like this, and they moved upward from left to right. Then you could have perfect negative linear correlation, and so that would be a set of points that were perfectly lined up and they went downward from left to right. And then you have somewhere in between, right? And so this is perfect negative, right? The best you can get. And this is perfect positive, but most of the time your data is going to be somewhere in between. So in this question, it said that we had an R value of 0.85. So that is, let's say, somewhere around here. And that is pretty strong. If you ask me, you're more than 50%. You're getting kind of close to +1 there. Pretty strong positive. So this one looks like a good answer, actually. There is a pretty strong positive linear relationship between sales of firewood, right? Sales of firewood and cough drops. Okay. And this is interesting, right? Why would there be a positive relationship between the sales of firewood and cough drops? Is it because firewood causes coughing? Well, not directly, right? But if the weather's cold and you're needing more firewood, you're probably also getting more colds and needing more cough drops. So that's not a causal relationship, but there is certainly a correlation, and that correlation happens to be linear or it looks to be linear because we have such a strong linear correlation coefficient. The second option is that fire must be the cause of coughing. No, that's silly. Well, I mean, it can be the cause of coughing, but that's not what we draw from this because there's other reasons that your cough drop sales could go up, right? The cold weather, like I said, would be the underlying factor because not everybody who develops a cough is necessarily also burning firewood, right? Temperature is a possible lurking variable that is behind this relationship. Oh, I like that answer too. Um, D, both A and C are true. Ooh, even better. And then none of the above. So I'm going to go with D there. Yeah, it feels so good to see that nice green check mark. Okay, so that was all of the questions my online students in statistics sent me for this week. So I will look forward to quote unquote, seeing you in next week's recording. Of course, you can always come to see me during office hours too. Take care.